Welcome, everyone, to another edition of the Data Resilience SpectrumCast. Steve Kennison here with my co-host, Randy Arsenault, and our two subject matter experts, Trisha Jang. Trisha, welcome back to the show.
Thank you.
And Sean Sperry. How you doing, Sean?
Peace.
So over the last few weeks, and we're going to continue this throughout the next few episodes, we're talking about the 6 key things in order to build a data resilience environment. So to recap, you've got the administrative security for your applications. You've got the ability to monitor your applications and your data. The third one, pervasive encryption, which is what we're going to cover today. You've got the multiple forms of the multiple forms of protection, air gapping, and automation. So today, as I said, we're going to cover encryption. A little bit different show. Randy has found some fantastic information about encryption, and we've got a few tooltips around encryption. So with that said, I don't know that we need to truly define encryption other than the fact that the latest edition of the IBM Ponemon Cost of a Data Breach report is out. It came out a week ago, and I'll put the link in the show notes here. And I highly encourage people to sign up and take a look at it and read through it. One of the things that they actually mentioned in this particular report was that the impact of encryption on the cost, on an average cost of a data breach, if you have high standards of encryption, it would cost you about $3 million when paying back your ransom, I believe. When you have low standards or no encryption, it will cost you about $1.5 million more, right? So they're really starting to call out some simple things you can do in your environment. And I think Randy's going to point out what does simple really mean in your environment to actually think about turning on encryption, making encryption available, and that sort of thing. So Randy, maybe we just pass it to you. You kind of had an interesting article you'd found about encryption.
Yeah, before we get into that, it's interesting. I think it's always useful to attach, empirical data to these things that we talk about sort of subjectively and more in the abstract and anecdotally. And that's a good one, right? So, we talk a lot about the cost and complexity of good security and encryption and protection and, data resilience, but scale that 3 million versus say $4.5 to $5 million cost. If that's the average, imagine you're a Fortune 100 corporation or something. It's going to be, a hell of a lot higher than that. And even at that scale, $1.5 million is a non-trivial delta. And you can probably significantly improve your overall data resilience and security and compliance and resilience posture. So I found this article that does a pretty interesting job, I think, of presenting some of the mythology around encryption. So because today's topic is encryption, I thought this was pretty relevant. So let me just kind of throw this up on the screen here real quick. So a couple of things, questions that I have as somebody who's not as familiar with the role encryption plays in an overall, data resilience strategy. And you can see some of them are pretty straightforward, like encryption is only for organizations that have compliance requirements. Well, obviously that's no longer the case, in this brave new world of, daily cyber threats and ransomware attacks. I think, we would agree that encryption is something that really should be pervasive everywhere. A couple of the issues or a couple of the kind of myths relates specifically to key management. And I know that's something that we've spoken about a couple times in the past. So I don't know, Sean and Trish, maybe you can help me understand this a little better. What do we do? I guess that's the first part of the question, to optimize and manage and streamline the key management process and secure the key management process. And part 2 of the question is, how important is that in the overall scheme of the client's kind of data protection strategy?
So what we see a lot with the key management is, first of all, you got to ask, where are you encrypting? Because encryption can happen at a lot of different places in the data lifecycle. So you can be encrypting on the primary source. You can be encrypting when the data is being sent over the network. You can be encrypting in the backup storage pool, or you could even be encrypting on the tape. So you've got all these different points and different encryptions going on. And so it really becomes critical to your question on where is that key management happening. And so one of the nice things with Spectrum Protect, and this is actually my tool tip of the day, is that when we do the encryption in the container storage pools, is we manage the encryption keys. The Spectrum Protect server does. And obviously the great thing about that is then if your data is either sitting on your Spectrum Protect server in a directory container, or if it's sitting out in the cloud, that backup data has been encrypted as well as deduped and possibly compressed.
Mm-hmm.
And then we're managing the key. Well, remember, you also want to be protecting your Spectrum Protect server database, all the meta information. And we just added a database backup for the Spectrum Protect metadata catalog that can go to the cloud. And as part of that, it sends the key database as well. So you have everything out there in the cloud. So should your primary site be attacked, you can do that restore of your Spectrum Protect server from the cloud, get back your encryption keys, get back your device configuration files and everything else. So that's really powerful.
So would that not introduce potentially another vulnerability, though, pushing your key store out to the cloud? I mean, I assume there have to be some precautions taken to make sure that doesn't create any vulnerabilities, right?
Yeah, there's other encryption and things going on top of that to make sure that that's protected. But yes, so that is double protected there.
Yeah.
Cool.
A lot of this comes down to an ease of use versus how much protection you're getting, and how, I guess another way to say it is how paranoid you are, right? And I think a lot of this has to come down to an evaluation of, you can get a lot for a little effort, shall we say, with Spectrum Protect and Spectrum Protect Plus. And that's something you definitely want to take advantage of. As you get to this, you can also take it to the level of a government intelligence agency or something like that, where you're expending a lot of effort, and yes, you are getting some more protection, but is it really worth it, right?
Yeah, I always assume there's kind of a diminishing return, argument to be had for some of this stuff. But again, going back to the point Steve made off the top, if your additional risk exposure is, millions of dollars, then even taking a modest step towards improving the quality of your encryption and the, reducing that vulnerability seems like a pretty smart investment. So,
yeah. But to add to your comment, Randy, and your comment, Sean, is that you've got to consider where in the cycle you're encrypting, because encrypting might impact something like deduplication. So if you're encrypting the data when the Spectrum Protect client sends it to the server using what we call client-side encryption, that's going to reduce the amount of dedupe we can do. So you do have to also think logistically, where am I encrypting and how is that going to impact the use of that data downstream? Yeah,
and there's interestingly, Trish, that leads right into another one of the myths here. And as a old school DBA, back in the Paleolithic era, I recall that things like encryption and data reduction were always, had to be implemented very cautiously because they could potentially have a huge impact on performance of data in flight and doing kind of large scale database operations. And I know that's changed. Some of it's being done in specialized hardware and ASICs and SOCs and things of that nature, and even network switches in some cases. So it's gotten a lot more sophisticated, which is good. And I think it's a continued evolution towards this, never-ending struggle of trying to keep pace with what the threats are and trying to have environments that are hardened enough to withstand them. So,
yeah, I think that what you mentioned with regard to performance hits is one of those classic "it depends" question, right? Some products, like I think our products, have done a very good job of implementing encryption and taking a minimal, if none, hit on performance, right? Whereas some other products might not have done that as well. So that's definitely one of the things you got to look at.
Yeah, when we introduced, for instance, in Spectrum Protect, the need to have certificates every time we did communications between the servers, the clients, the OC, the library managers. When we introduced that level of encryption and certification, that is only for the communication. That's not for the data. And that's a big difference. So you do also have to say, what am I encrypting? And so in the case of encrypting the communication, that added a high level of security at a lower cost, because that's very little amounts of data.
Yep.
And so you can think also strategically about this performance hit and what you're actually encrypting and where.
So Sean,
Yeah.
And we do have customers who are like encrypt everything everywhere, right? I mean, they are
Sure.
the highest security type of.
Well, and I assume that's kind of the gold standard, right? I mean, if
Right.
cost was no object and complexity was no object, I would certainly choose to have all of my end data encrypted through its full life cycle.
Yes.
I think, if we go back all the way back to the very beginning around the definition of data resilience, right? I always say that there's two components. There's the toughness, right? So it's no longer about if, it's when they get through. And Randy's proven that time and time again on the podcast that they're going to get through. The next thing is when they do get through, resilience is about how resilient is your infrastructure in order to be able to rebuild and get back to operational. There's two components to that. There's toughness, right? So how tough is your data against those types of threats? But the second thing, and I think more probable, and it leads me to a question which, Sean, I think you might have answered, but I'd like to expound upon it, is flexibility, right? You can lock all the data down such that no one can touch it, but then you no longer have a competitive business because lines of business need to have access to data in order to do their job and build things out. So why is it that people don't use encryption, Sean?
That's a very good question. I think I don't know the answer to that question. I mean, especially in this day and age, and given the technical products that I'm familiar with and that I work with on a regular basis, it's just so relatively easy to implement that I think there would be no reason why, other than, historically we did need this and we're just running like we did 5-10 years ago. I don't know,
would add
Trish.
that if you're using, for instance, a dated storage pool, so if you're, it doesn't have to be data, but if you're using, for instance, a file device class storage pool versus our containers, well, that doesn't support inline encryption. So perhaps then you wouldn't turn it on.
So I guess that to take it to the higher level, yes, there is some complexity in the architecture of these whole systems, right? And if I architected this system 15 years ago, it all works, right? Then there's reluctance to change it because it's working, right? And of course, you're increasing your risk.
I think at the end of the day, though, you said it, Sean, right? In a lot of the newer technologies or the more modern technologies that folks are implementing, it's kind of an easy thing to turn on. And given the climate, the data climate today, why wouldn't you, right?
Right.
Yeah. So before I leave this page, I just want to point out that finally someone agrees that Romeo and Juliet needs more zombies. So let me just get off this page so we can continue the discussion. So the things you find on Wired. I love Wired, by the way. So given all of these factors, right, considering the cost and the potential complexity and the risk reward calculations that go into this kind of stuff, what are we doing, or what is the industry doing to make encryption, number one, more pervasive, and number two, easier and more frictionless to implement? So I mean, as an example of what I mean by that, we've talked in the past about how IBM, on the forefront of quantum computing, one of the first major applications of quantum computing is security, and in the ability to both devise, more secure and hardened encryption algorithms, and also use quantum computing as kind of a test bed for threat vectors and ways to exploit these environments. What else are we doing in the broader sense to improve the viability of encryption?
You're a good straight man, Randy. Thanks for the setup. It is interesting. We have applied, starting at the end of last year, the tape team in Zurich has taken the quantum computing and done applied quantum encryption to our tape to be able to be used within our tape libraries. So I reached out to the development team over there, and what they had told me was that yes, they have kind of a process to use quantum encryption in our tape libraries. And what they've done is they've submitted that to the standards body, NIST. And so when NIST finally defines this de facto standard, I think what they were trying to do is have consistency among kind of all the applications. If you write to tape, that everybody reads the tape the same way and writes the same way, et cetera. When they define the standard, we can easily turn it on and implement that. And what I find interesting about this, just one last piece, is just like safeguarded copy, the component that we added to our high-end DS8000 systems a year ago, once it got traction in the field and we understood it and we kind of worked out any kinks and it was well understood, it then morphed its way, as we announced last month, into our flash systems portfolio. I envision this encryption doing the same thing. We'll get it solid, it'll get some hours underneath it in the tape, and it'll slowly, that level of encryption will slowly move into the portfolio.
Cool. Yeah. And again, that's where, something else I beat the dead horse about is that it really is advantageous to have access to all these other research initiatives and really smart teams of really smart people within IBM that are thinking about these things and have the domain expertise in security and encryption and, kind of data movement and encryption in flight. So I think that's one of the things that allows us to offer such a robust portfolio of solutions from end to end and from edge to core to cloud that really is resilient and encrypted and secure. So that's a good thing.
Right. Team, I think encryption, I don't think we need to speak too much more about encryption. It's one of those things, as Sean said, a lot of the capabilities are built into these new software solutions. It's definitely a must in today's data climate, and I think we should be using it. So there's number 3 of the 6, and I look forward to next week we have off, but the week after we'll pick up with the multiple forms of, I'm not even going to call it backup, the multiple forms of recovery, all the way from on-device protection with snapshots and our new safeguarded copy, all the way through to streaming backup, whatever your backup solution is. So, and
just a teaser, I think we may be presenting or producing that episode from a secure remote location, which will be disclosed at a later time.
Which would be pretty cool.
Yeah.
And we'd even be in the same room, socially distanced, maybe.
Of course. Yeah. 2 meters.
All right, gang. Hey, thank you all very much for your time today, and we look forward to our next one.